So we need to show that the triangle given by ABC, it's an isosceles triangle. If we have the condition that cosine of angle A over A equals cosine of B over B. Here A and B represented in lowercase represents the sides of the triangle. For this we're going to use the law of cosines as stated here. We have a triangle ABC. The sides opposite to angle A, B and C are represented by the letter A, B and C in lowercase respectively. Then we have cosine of angle A, B and C. So that's given by the respective sides. Let us begin. So here we'll start with cosine of A, whatever is given to us. We are given cosine of A over A equals to cosine of B over B. So let's use the value of cosine of A. So that's B squared plus C squared minus A squared divided by 2bc. We also have a multiplied to it, so this will be equals to cosine of b, so that's a squared plus c squared minus b squared divided by 2ac, and we have b multiplied to the denominator. Now clearly the denominator factors out, and now we are only left with the numerator, which is b squared plus c squared minus a squared, which is equals to a squared plus c squared minus b squared. Now we can cancel out c squared from both sides, and that leaves us with b squared minus a squared equals to a squared minus b squared, or simply put 2a squared will be equals to 2b squared, and solving this we get a equals to b. Now we know that whenever two sides of a triangle are equal, then it clearly states that triangle ABC must be an isosceles triangle. Since we have successfully showed that our given triangle ABC, that's an isosceles triangle whenever cosine of A over A equals cosine of B over B, hence proved.